All right, let's take a look at page 3. What rigid motion maps the solid line figure onto the dotted line figure? So we're going from here to there. Now, as far as rigid motions, there were a few different ones that we talked about. Rigid motions, once again, our shape is not changing size, it just might be changing position. So we have translations, okay, where our shape would kind of shift left and right, up and down, or a combination thereof. We also have rotations, where our shape would rotate around some central point into a new position. We had reflections as well, where it would be reflected over some kind of a line, imagining we had a mirror. If we had a position between the two, did it reflect over that line to make the new shape? But in this case, we can see that we just see this shift from this position to this new dotted position over here on the right-hand side. So therefore, this is a translation. Okay? Taking a look at number 8. Point P prime. P prime is located at -3, 2, and it is the image. So P prime is the image of the point P, which was located at 3, 8 under a translation. So it shifted left and right, up and down. It shifted. It didn't do any rotation, didn't do reflection. It just moved around someplace on our coordinate plane. Okay, so what is the image of 0, -6 under the same translation? So what we want to kind of think about here is that we started off at point P, and we went to point P prime. Okay, so how did we get there? Well, point P was over at the location 3, 8. It ended up over at the location -3, 2. So what does it take to get from here to here for our x's and our y's? So let's think about this for a moment. Okay, well, we can see here that if I need to go from a 3 to a -3, how do we get there? Well, if you have a 3 to a -3, just subtract 6. Okay, same thing with our 8. If I'm going from 8 and we end up at 2, we just subtracted 6. So our translation rule we're going to see here is that we're going to take our x and y, and we're going to subtract 6 from the x's and subtract 6 from the y's. Okay? So if we are now, our image is located, okay? So what is the image at 0, -6? So we're going to apply this translation to that point. Okay? So we're going to try that translation at that point. So that's going to be our 0, -6. Well, -6, we're going to add that together. That's a -6. -6 added with another -6 is a -12. So where is that point? Well, the image of that new point is going to be located at -6, -12. Put a box around it because we're done. Let's take a look at number 9. Now, number 9 here says, what theorem shows that triangle TNP, so TNP, the one up at the top here, is congruent to triangle TMQ? Now, for this, we need to see what we have here. Now, there's a few different ways that we can talk about congruency. Now, we have side, side, side congruence. We have side, angle, side congruence. Angle, side, angle congruence. Angle, angle, side congruence. And we even have hypotenuse leg congruence. Now, hypotenuse leg only works if we have a 90-degree angle. We don't know if we have any 90-degree angles, so we can kind of discount thinking about hypotenuse leg. But let's see what we have here. So we have one side and one more side. Now, if we wanted side, 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 we'd need a third side. But we don't know anything about NP or QM. So we can't have side, side, side. Our HL we'd have to know a right angle, so we can kick that one out. So now it's one of these. Notice that since we have two sides, we need one angle. Okay? Well, if I've got two sides and I need an angle, the angle needs to be between the two sides, and in which case we can see that this angle is congruent to this angle. Well, how do we know this angle is congruent to that angle? Well, this angle PTN and QTM, these are vertical angles, and vertical angles are congruent. Okay, so notice that our angle here is between the two sides. This is the included angle. So it's going to be side, angle, side, congruence. Okay, let's take a look at number 10. So what additional piece of information is needed to show that triangle GHJ over here, is congruent to triangle MNP by side, angle, side? Well, let's see what we have. Well, we have a side and an angle, a side and an angle, right? We already have a side and an angle. We need another side. Well, the side, once again, has to be on both sides of the angle. The angle is in between. So we would need to know this side on these two triangles. So we would have to know that GH was perpendicular to MN. Okay?